Hey guys, welcome to this video lecture series on the subject of energy technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have just introduced the chapter of nuclear energy, in which we have seen two different types of nuclear reactions as nuclear fission and nuclear fusion reaction. Well, mainly we are focusing on the nuclear fission reaction. Then we have seen the different fuel that are used for these nuclear reactions. Then we have seen the typical fuel cycle for this nuclear energy as mining, milling and different operations such as reprocessing, use of this fuel and disposal of waste generated in the nuclear reaction. Well, if you have missed that video, you can find it on the I button over here. Now in this video, we are going to start the new topic of storage and transportation of nuclear fuel. Well, transport is an integral part of this fuel cycle. There are many operational nuclear fuel plants that generate electricity, but there are very few locations where we can find this uranium as a fuel for the power generation. The transporting nuclear waste required sturdy container that can shield it from the radioactivity. So, such material or such fuel for the nuclear reaction are very radioactive. They continuously emit radiation that is harmful for the human body. So, we always required specific type of container or special type of tanks that can store such fuels. Well, a specially designed container is used for this purpose. There are different type of such containers for different purposes, but they all have similar overall design to minimize the containment of radioactivity. Here in this image, you can see that typical example of such transportation of fuel by means of specially designed container that can reduce the radioactivity to its minimal level so that we do not harm any living beings on the planet Earth. Now, let's move to the next topic of this chapter, and that is uranium enrichment. Well, uranium enrichment is the process that is necessary to create an effective nuclear fuel out of mined uranium by increasing the percentage of uranium-235 which undergoes the nuclear fission with thermal neutrons. So basically this uranium enrichment process is nothing but the increasing the concentration of uranium-235 in the ore of this uranium that we have mined from these different mines. So this enrichment requires a uranium to be in a gaseous form due to varying chemical and physical property that different isotopes such as uranium-235 and uranium-238. These differences are most easily utilized and manipulated when uranium is in the gaseous form. So the first criteria for the uranium enrichment is that this uranium must be in the gaseous form, as it is easy to treat and manipulate the property of gaseous uranium compared to the solid form of uranium. Firstly, the uranium oxide concentrated is dissolved into the nitric acid, which creates the uranyl nitride. This uranyl nitride is then purified, evaporated and finally thermally decomposed to form uranium trioxide powder. After which there are two clean processes where this uranium trioxide is converted back to uranium oxide, then it reacted with hydrogen to form hydrogen fluoride to produce uranium tetrahydrofluoride. So finally this UF4 is fed to the reactor chamber. So what we do is this gaseous uranium is reacted with HNO3 and then it is produced uranyl nitride. And this uranyl nitride is further reacted to produce uranium trioxide, which is then converted into uranium dioxide and reacting with fluorides. So it produces uranium tetrafluoride, which is the feed for the different reactors. So this was all about the uranium enrichment process, in which we increase the concentration of uranium by dissolving this gaseous uranium into nitric acid, and ultimately we get this uranium tetrafluoride. Now let's move to the next topic, and that is different reactors that are used for the power generation by utilizing nuclear fuel. So the first reactor is breeder reactor. Well, this breeder reactor is again very important for the exam point of view. This question has been asked for 7 marks for the university exam. So a breeder reactor is the nuclear reactor that generates more fissile material than it consumes. So basically this breeder reactor is nothing but a special kind of reactor which generates more fissile material than it consumes. So what does it mean? Well, the breeder reactors achieve this because of their neutron economy is high enough to create more fissile fuel than they use. So the whole process is about generating the fissile material that can undergo the nuclear reaction and generate heat energy to produce electricity. By irradiation of uranium-238 or thorium-232 that is loaded into the reactor. So the breeder reactor uranium-235 is fissile material. That means it is capable of sustaining nuclear chain of reaction. So what does this fissile means? It means that any fuel or material that is being capable of generating continuous nuclear reaction and producing chain of such reaction, so that heat energy is being generated and that can be converted into electrical energy. So uranium-235 is the fissile material. But the availability of this uranium-235 is very limited. Around 0.7% of total naturally available uranium is in the form of uranium-235. While the rest of uranium, around 99.2%, is in the form of uranium-238. Well, this uranium-238 is again not fissile material. So it cannot create the nuclear reaction and it does not generate any chain of reaction. So breeder reactor utilize such non-fissile material on which neutron is being bombarded, and it convert this uranium-238 into the uranium-239, which loses 2 electron and transform into the plutonium-239, which is again the fissile material and can be used as a fuel for the breeder reactor, and thus the breeder reactor produces more fissile material such as plutonium-239 than it consumes the uranium-238. So what does this breeder reactor do is, it convert this uranium-238, which is again non-fissile material, into the plutonium-239, which is the fissile material. So now let's understand the most utilized breeder reactor, and that is liquid metal fast breeder reactor. Well, liquid metal fast breeder reactor have a mixture of non-fissile uranium-238 and fissile plutonium-239 as a fuel. This fuel is being surrounded by blanket of uranium-238. This blanket capture the neutron produced in the fission and transform this into the uranium-238 to the plutonium-239. So such liquid metal fast breeder reactor has mixture of uranium-238 and plutonium-239 as their fuel, and their core is being surrounded by the blanket of uranium-238, which is again non-fissile material. So inside the core there will be nuclear reaction which generate the neutron, and this neutron will strike the blanket of uranium-238. This uranium-238 will be converted into the plutonium-239, which is again the fissile material that can be utilized for the continuous sustainable chain reaction. Unlike other conventional reactor that uses water as the coolant, liquid metal fast breeder reactor utilize liquid sodium as the coolant. Because of it does not absorb neutron as much as water does, and its thermal conductivity is higher than the water. Here in the image you can see that typical example of liquid metal fast reactor, in which the orange side shows the nuclear reaction core inside which the nuclear reaction is being carried out, and this fission reaction produces neutron. In the animation on the left hand side you can see that this neutron is being bombarded on the uranium-238, so that this uranium-238 converts into the plutonium-239, which is again the fissile material. The heat energy is now utilized to heat up the liquid metal, and this liquid metal is then sent to the secondary loop, in which it turns this water into the steam. So this high pressure steam then runs the turbine and generator section in the usual manner in order to produce electricity. So now let's see how this typical liquid metal fast breeder reactor works. As the fission reaction occur in the core, the liquid sodium in the primary loop transfer heat to the intermediate liquid sodium loop through the heat exchanger. So here in the image you can see that the heated up liquid sodium transfer the heat to the secondary fuel, which contains water. So the heat from this liquid metal sodium is then used to generate steam from the water. Here in the image you can see that the steam is generated, and this steam is then further sent to turbine section to run the turbine and drive the generator in order to produce electricity. The reactor can be refilled with uranium-238 once all fuel is being consumed. So it was all about the liquid metal fast breeder reactor. Now let's see the second type of nuclear reactor, and that is boiling water reactor. Well, boiling water reactor produces steam directly in the reactor core, while the reactor, like pressurized water reactors, have steam generator to produce steam. So in the previous reactor we have seen the separate loop is used to convert this water into the steam, while the boiling water reactor does not involve any secondary loop. In the main reaction core, this water is directly converted into the high pressure steam, which is driven to turbine and the generator. So the feed water is sent to reactor pressure vessel or core through the nozzle. As the reactor core is at very high temperature, and heat of this nuclear reaction of this fuel turns surrounding water into the steam. So here in the animation you can see that how we are converting water directly into the steam by means of pressurized nuclear reactor, inside which continuous nuclear reaction is being carried out and huge amount of energy is released. This energy is directly utilized to convert water into the steam. Then this steam drives the turbine and generator section in usual manner in order to produce electricity. We can condense this steam back to the water by using cold water. So here in the diagram you can also see the working of boiling water reactor. As this water is converted into the steam, and this steam is then sent to the separator, and then it is dried and it is sent to the turbine section to produce electricity. Well, this steam is always dried so that we can remove all the moisture in the steam. So we can reduce the corrosion of such bulky parts in the turbine section. The steam which drive the turbine get cooled in the condenser and is converted into the water, and it is recycled. So in order to control the nuclear reaction inside the core, controller rods are used. They control the nuclear reaction. So if you want to increase the nuclear reaction, you can remove this control rod, and if you want to reduce the reaction rate, then you have to insert these control rods. So this was all about the boiling water reactor. Now let's see the last type of nuclear reactor, and that is pressurized heavy and light water reactor. Well, the characteristic of pressurized water reactor is the pressurizer, which keep the working fluid under the pressure. So here in the image, you can see that one pressurizer is being used to pressurize the working fluid. In the primary coolant loop, the demineralized water is used as the coolant. The temperature of water while entering the reactor is around 275 degrees Celsius and increased to 315 degrees Celsius as water is heated. A pressurizer is used to maintain pressure in the reaction vessel. So, here in the image you can see that the hot water from the primary loop is then sent to the heat exchanger to the secondary loop. This allows the water of a secondary loop to boil and convert into the steam. This steam is then sent to the turbine section to produce electricity. Now the secondary coolant or steam is then sent to the condenser for the cooling purpose. Thus, water is obtained and sent back to the steam generator. So, in the pressurized reactor, we always use the steam generator as the secondary loop, which converts water into the steam. A pressurized heavy water reactor, that is PHWR, is the nuclear reactor that uses heavy water as D2O as its coolant, while light reactor use normal water as the coolant. The light water absorbs too many neutrons to be used with the unenriched uranium, and therefore uranium enrichment process becomes necessary for such light water reactors. So, this concludes all the nuclear reactors that are used for the nuclear energy. Now, let's understand different nuclear waste management. Well, the waste generated from the core and different part of this nuclear power plant is very dangerous for the living beings on the planet Earth. Hence, this waste need to be carefully managed so that no hazard take place. Some type of nuclear reactant or the product take much longer time to reach the level where they will do not emit harmful radiation. Hence, many countries deposit such material underground. Fuel such as uranium, after its use, the waste is generally deposited under the deep level of the ocean. So, we can deposit the waste from the nuclear plant under the ocean as well. Sometimes the nuclear waste is deposited in the special designed container called as cask. So, this cask kind of container are specially designed to restrict the radioactivity of such fuel. Well, if you want to understand what nuclear reaction and what nuclear power plant can do, you can refer the disaster that have taken place in the Chernobyl in 90s. Well, this concludes the chapter of nuclear energy. We will see you in the next video. Till then, keep watching, keep learning. Thank you.